Good afternoon, and thank you for joining us for today's webinar on the topic of predictive maintenance. My name is Eric Trower, and I'm a member of the marketing team at SICK. SICK is a leading provider of sensor solutions. Today, we welcome Divya Prakash, or DP as he's known in the halls around here, and DP is SICK's Director of Business Consulting for Industry 4.0. Today, he'll be discussing the increased importance of predictive maintenance, different maintenance approaches with and without sensing technologies, and the opportunities for predictive maintenance in a variety of industries and settings like manufacturing, energy, transportation, utilities, healthcare, and more. If you have any questions throughout our webinar that you'd like to have answered, please type them into the chat section on the right-hand side of your WebEx control panel, and we'll be happy to answer those following the presentation. I'd also like to mention that a recording of this webinar will be emailed to those who are registered. With that said, I'm going to pass it over to DP.
Thank you, Eric. Good morning, good afternoon, everyone, depending on where you're joining us from. As Eric said, my name is Divya Prakash. The topic today we are going to be discussing is predictive maintenance, more transparency, less downtime. And as we go a deep dive into this topic, I'm going to take a few steps backwards to tell us and discuss where we are coming from and where we are going. So just a little introduction of myself. My name, as Eric said, Divya Prakash, but I go by my initials DP. I've been in this industry working on industrial automation projects on the business side as well as on the shop floor side, connecting the IT OT systems. My specialization is in Industry 4.0 and looking at implementing automation and information solutions, and now with the cloud computing, the edge computing, and other aspects as well. So predictive maintenance, when we hear the word predictive maintenance, I mean, a lot of people construe this word differently. You will hear me talk about a lot more terms like condition-based monitoring, reactive maintenance, prescriptive maintenance, other stuff. So what really predictive maintenance means is we are moving away from an uncertain standalone niche use case to a fast-growing, high return on investment application that is truly delivering value to users. So you have heard lately in the conversations going on about, artificial intelligence, OpenAI, ChatGPT, machine learning, and then Internet of Things, or industrial Internet of Things in case of manufacturing. Those aspects are all coming into the picture right now, and it's providing us more tools, more analytical tools to understand how our machines are running, how our shop floor is running, how the whole plant is running, and so that we can have a better insight onto the health of all the assets, and we can take action before something catastrophic happens, or even if some downtime happens as such. This is a quote from one of the news magazine, Manufacturing Global, according to an article published in March 2021 by the news magazine. This was way before the ChatGPT became very popular or more prevalent in a conversation. 98% of businesses report that a single hour interruption affects their productivity, costing them more than $100,000. Now, again, that number is relative to the industry you are in. Whether you're automotive or you're in pharmaceutical, those numbers can change a lot. However, predictive maintenance solutions have the potential to minimize unplanned downtime and prolong life of machinery. So this is the background where we are coming from. The businesses, the manufacturers, and the customers are looking for a way to minimize downtime and how to keep the plant running, and basically, get the maximum throughput to your plants without any downtime. This is a chart that was put together by IoT Analytics, online analysts out there, based on the Google searches that folks are doing on predictive maintenance. If you can see the charts out there, predictive maintenance is on the rise. More and more people are looking at how can I have something in place to do predictive maintenance. And the preventive maintenance line that you're seeing is slowly declining as to why do you I want to do preventive maintenance. And I'll give you a good analogy here. In the past, we used to do oil changes on a car just for 3,000 miles, or 3 months. Needed or not needed, doesn't matter. We used to, at least I remember based on my age, I should drive over to Jiffy Lube, get it done, because 3,000 miles in 3 months. That was the preventive maintenance that we used to do. Now my car tells me when I need an oil change. There's sensors on board that tells me my oil life is like 60% or 30%, and then when it gets closer to 10%, of course I'm a little paranoid, so I always do it before it goes to zero, and I change those. So that's what happens. And then if you see at the bottom, the red line, the proactive maintenance, that is like almost zero, because that is where you do stuff. And back to my Jiffy Lube kind of example, you just do it because you want to be proactive, but you're not maximizing the use out of the oil that is already in there, using my analogy of oil change. So you don't do that. And so that is the waste of your resources of perfectly good oil that would have lasted you a few more thousand miles or a few more months, but then you just changed it just because you were a little bit, you were being proactive. So this kind of shows you where the industry is changing out there. And so let me take you a little bit back in the typical maintenance approaches that have been out there in the past. The one on the left, which I call reactive maintenance, everybody is aware of it. At least in my house, we are. Something breaks, you call the people, you buy a replacement, and you replace it. So you're acting after the incident. So there's really no predictive. Now, if you want to do that in a manufacturing, plant, or basically the whole production stops, especially if it's critical to your whole manufacturing, because the machine went down and then you have nothing. Now you're scrambling for spare parts, you're scrambling to get, and then nowadays, especially with the supply chain issues and others out there, you may not even get the part for a few months out there. So that is reactive maintenance, the reactive service acting after an incident. So what happens? You have high downtimes, but it's the easiest to implement. You do nothing. You just sit. You wait for something to fail and you go do it. Well, if you're running a business, that's not the model you want to run, because then all of a sudden everybody's idling, the machine's idling, the plant's idling, and there's nothing being produced. So you're not making money. So let's go to the middle option, which is preventive maintenance. This is back to my analogy of the oil change. Cyclical service intervals, you just go every 3 months, you change it, you regular actions to minimize. And if you look at the chart out there, you know that typically based on your history or your past experience, that that the bar graph is kind of going till you see that green thing where it's X, where it says still usable conditions. So that is where I am safe, because I know that's how far it can run. And anytime before that, if I make my replacement or do my maintenance activities, I should be good. And then this whole cycle starts again, and then we go down this path. If you look on the top, I forgot to mention that at the very beginning, the title, it says without sensing technologies. So here we do not have any sensors that are reading anything on the condition, on the health of the asset or the machine or whatever it is. This is purely based on your experience, your gut feel, your past understanding, or some places you may even do it based on statistical, I've always run it and it runs for that long. So looking at the preventive maintenance, as I said, that's cyclical service intervals. You just change it. The analogy of the 3,000 miles, 3 months oil change we used to do in the past. And it's the regular actions to minimize the risks of incidents. So you're doing that before you have something goes, but in the process, you are throwing away, if you see that little dash line, that much level of good product or good condition that you could have still squeezed out and minimized the cost that is involved in putting in a new one. So, but what does that really mean in the manufacturing? Now you have a high use of resources with the residual risk. So now you have people walking around in your plant doing all this maintenance, even if it's not needed, because things are still running fine. So this is the preventive maintenance, but that's the downside of the preventive maintenance. But it is a known approach. We all do that. We water our plants every day. We know it needs water. None of us are putting, if we had and we could afford it, your farms are doing, So you have your own business case, you have your own aspects, and this is what happens. So let's move on to the right side, and that is the proactive maintenance. So it's very similar to preventive maintenance, but you have a window, optimum time to schedule maintenance. You know that based on your past history, that at where the red X is, that's where things fail. This is where you are today. So you have so much time left for you to take action. So you're forward looking, you know that within the next 2 weeks, if I get a chance, if I have a downtime in my manufacturing facility, I should be able to go and do the change, because that's where I am seeing, that's where I'm seeing that I have a window. It's not going to fail tomorrow. It's not going to fail the day after, but I have this window that I need, if I can squeeze some time in without compromising on my running and throughput, I can, as soon as I have a downtime, I'll go ahead and do that. So it's basically act before an incident. Well, from a negative side, a lot of initial efforts, but it's highly effectiveness, because you know that you have this window, and then you can do the maintenance without impacting your production. So, but these are the approaches you take without sensing technologies, right? You're just doing it based on your gut feel, based on your experience and your last historical data of when these machines have failed in the past and moving forward. Now let's look at approach which we are doing with sensing technologies. This is where we actually bring in a sensor and we measure the health of the machine. So one of the most common and which is available today it's called condition-based monitoring. You put the sensors in there, it measures certain variables that are out there. And I'm going to go back to my analogy of the oil in a car. There's a sensor that's measuring the the clarity of the oil to see how dirty it is and how burnt it is, and then it judges from that the life, and then tells you that your oil is slowly becoming dirty. It's time to go change your oil. And that is being done by the sensor, that's being done by the analytics that is on the sensor. And so you're not changing something if you didn't use the equipment for 6 months and the oil is as good as new and sitting out there. But if you went with the earlier approach of time bound, or you would still change it. Here you're minimizing that, so you're not wasting your effort on task that is, I wouldn't say redundant, but it's not needed immediately. But so that is condition-based monitoring. So maintenance done when equipment problems have been registered. So the sensors registered some problem with the equipment, you go do it. If everything's running hunky-dory, everything is good, you have time, you don't have to do anything. You can rely on the sensors telling you when it is. And it is easy to implement with, whether it's an existing sensor, you can retrofit those with putting some others, or if you already had some vibration sensors or something else others on board, you could leverage those. So this is condition-based monitoring. This is talking about putting one sensor in there, looking at the values coming back from the sensor, and then making your decision based on what the feedback that you're getting from condition monitoring. Now let's put some analytics on top of that, right? And that's where we move to the center side, which is predictive maintenance. Predictive maintenance is where you're looking at the values that you're coming from the sensors, and then you're putting some analytics tools on it. So for example, you're adding some statistical data, you're putting stochastics, real-time analytics. Nowadays, you'll hear a lot about machine learning. So you're building a model, and you can put those on top, take the reading based on other stuff that affects it. You can do this on premise in your plant, or you can push this data into cloud and do a big data analysis based on other conditions that impact the machine. And the bottom line is the equipment failure is predicted. And it gives you a little better insight as to what could be the cause of the failure. Is it, for example, if I talk about a motor, it could be the motor's bearing is going. It could be the motor is getting misaligned, so it's vibrating a little bit. And these are using some of the examples. It could be that there's some heavy load on it, and now it's drawing a lot more current. So it could be a lot more stuff, and you'll get those feedbacks from the sensors, and then the sensors, now you'll do the analytics on top of that based on your past understanding and history, and then predict what is the failure and when it's going to happen. Now let's move to the right one. This is more futuristic, and it's happening right now, but it is not widely prevalent in the industry. So prescriptive maintenance. What does that really mean? That is now taking it to the next level. You know, where the machine does the predictive maintenance, diagnostics, and then automatically diagnoses itself, and then sends a message or schedules a maintenance. Sends the data over to the maintenance department saying, hey, I am having problems. This is the problem I'm having. You better fix my whatever the problem is, and you only have 6 days before I totally fail. No, it's completely automated. This is highly effectiveness. This is where we are going. This is what we call prescriptive maintenance. Most of the right now, it all starts with the sensors. It starts with condition-based monitoring, which is the smallest. I use the example of Lego blocks. That's the smallest Lego block, which is condition-based maintenance. You take these sensors and these Lego blocks, combine them with your analyticals tool, which is another Lego block, and now you have a bigger Lego block called predictive maintenance. Then you add the self-diagnosis and alertings. And somebody jokingly told me the machine should be able to send a tweet by themselves saying that I got a problem to the maintenance, or a text message. And it may sound funny nowadays, but it is happening. It is getting there. It will happen with all the new tools available to us, with analytics tools and other stuff. We would be able to do a little bit more diagnosis, better diagnosis, and schedule all this stuff so that we are optimizing the use of our maintenance technicians and other people that we have. So this gives you a little bit the setting of where we came from, what is happening, where we are going. What I wanted to talk from here, moving on from here onward, is more on condition-based monitoring, because that is the foundation on which all this stuff is built on. We understand predictive maintenance, and if I had to cover all 3 topics, this would be a long webinar. So I'm just going to be just talking a little bit on the condition-based monitoring maintenance. Now, at the end of the webinar, if you have questions on any one of this, we can get into those for discussion purposes, but let me go just on condition-based monitoring. Now, on condition-based monitoring, there could be multiple conditions we can monitor, right? And I gave some examples of vibration monitoring. That's one way. Some people have audio monitoring to see if the machine is making I'll use an example, a motor, when it is running and all of a sudden it's screaming because it's running much under load and it's making noise. That is another way to know that something is wrong. It's screaming a lot. So there's different sensors, different parameters. I talked about current sensor that can measure the amount of amperage that motor is drawing. So we know that something is wearing out and is pulling a lot more current, or there's resistance. Maybe the bearing needs to be lubricated because it's getting dry. So it's drawing more amperage. So these are the sensors that go in for condition-based monitoring. The one that I'm going to focus on mostly in discussion moving forward is vibration analysis, okay, or sensors that do vibration analysis. But before I jump into that, let's look at where are the opportunities for this predictive maintenance. And I jokingly say anything that shakes or rattles needs vibration analysis, needs the predictive maintenance, because it can fail, it can die, you know, because it's shaking, vibrating, and someday something will get loose or fall off. So manufacturing definitely needs condition-based predictive maintenance, right? Energy sectors, you know, same thing. Transportation, Eric mentioned that in the introduction, you know, utilities. There are other industries like mining, healthcare, anywhere. I always say, I mean, anywhere we can measure the condition of something, whether it's health conditions, we can have predictive maintenance. We can apply that out there. So this is a wide topic, but we will restrict ourselves to manufacturing right now in the discussions moving forward. And what I'm going to use just to convey this condition-based monitoring concept is using vibration analysis. So let's take, I'm going to use the example of our multiphysics box, which is a multiphysics, we call it multiphysics because it measures more than one. It measures actually 3 different variables and it's really, really a very powerful tool, and it's no bigger than a quarter. If you want to look at the size of it, it's a little bigger than a quarter. Uh, I won't say a dime, a quarter. And it has a lot more capabilities built in this small little sensor. So this sensor from SICK is designed to measure temperature, which is if you mounted the surface temperature on top of the motors or pumps or whatever, that any device, it measures vibrations in all three directions, X, Y, and Z coordinate. And then it also measures shock. So if, for example, you have it on a motor and it gets hit by a forklift or a big truck or something, it'll measure, and it can measure up, up to 200 G of shock. So you know when it happened, who hit it. It's a good way to know that this motor needs to be in a different space because whoever is driving by is hitting it, and the sensor will fail. Though it has nothing to do with the actual operation of the sensor, it's the external factor. So you can get both the running of the internal diagnostics and externally people affecting it. So shocks and vibration temperature. This is a good example of one sensor measuring all these three conditions and giving you a health of the device that it is mounted on, and then you can take action on it right away. So why would we do something like this? In a manufacturing, why would you do a condition-based monitoring? Why would you want to do it? I'm happy, I'm running, going back to saying if something fails, I'll fix it, right? Well, you don't want anything to fail. You want to know before it fails so that your production keeps going. So if you want to extend a machine lifetime, you want to extend the machine's availability so I can keep making products. I want to reduce my maintenance costs so I don't need too many maintenance people running around trying to fix it. And then, of course, I want to increase my production quality. I want to increase my throughput. So how am I doing that? I'm doing that by condition monitoring, where I monitor based on my critical assets, I monitor their condition, and then I do the diagnosis of the data that I have. How do I do that? There's different ways and different complexity or different scenarios where you can do that. You can do it as very simplistic, pop it on the machine, put a little stack light next to it, it turns red when you think some things are not going right. You can, any of these, when they deviate from the thresholds that you have set for them, they can go ahead and raise an alarm. If you wanted more analysis, you wanted to see the whole trend charts and everything else, you can bring that data out through a secure bridge gateway or edge gateway or something else and visualize that locally on a dashboard. Or if you want to do a big data analysis and you have a larger cloud infrastructure where you want to do with a lot more, we even have the capabilities of take this data and push it all the way up into the cloud where you can do with the big data analysis, the big AI and machine learning and all the other aspects we talked about earlier. So you can start small, very small, just at a small machine, most critical assets, and just measuring the vibration and others. You can expand it to have a larger installation across all your critical assets, or you can expand it to your enterprise and have an enterprise view of all your critical assets across multiple plants going forward. So let's look at the sensor. And I specifically want to show this sensor a little bit. And a lot of people says condition-based monitoring, we have all this other stuff. Look at how much complex this, how capable this sensor is, but how simple it is to install and to implement. So I talked about vibration. I'm not going to read all of these. You can read that on your own. But yeah, what I said at a high level, we measure on all three axes, X, Y, and Z, and it can measure up to 8G of vibrations. And then we have 3.2 kilohertz, block length. So these are not just the simple sensors that you used to have in the past. These are a lot more brain to it, a lot more analytics built into it, and I'll explain that as we go further out there. So it is not just a simple, sensor measuring just vibration or the shocks or the temperature. So the ranges are shown right here of this one particular product, that MPB10 that I'm showing right now. But this kind of gives you the idea that you're getting multiple things. You can measure the surface temperature. If the bearing is getting too hot, this will pick it up. If you get hit by something else externally, the shocks, it'll pick it up to 200 G. If it starts vibrating in one place because there's a misalignment of the shaft or the bearings wearing away and the pump's now vibrating in one particular direction, it'll guide you to what kind of problem it is and where it is happening. So, and the strong part of this is it's a little bit different. It's got smarts built into it. And this is where the condition-based monitoring is coming in. We don't just give you the raw data. A lot of times, the sensors out there, yeah, I got the raw data, but I don't know what to do with it, right? It is just, there's no shortage of raw data. Give me data that are, effective, that are actionable. I can take some action on it. So what this particular sensor does, in our case for condition monitoring or vibration analysis, it reads the values for a certain period, evaluates it for over the period, the root mean square of acceleration velocity of where the vibration is happening. We'll cover the more technical side in a future webinar when we get deep dive on the technical side. But to let you know that based on that, now you know which way you're trending. You're trending up, you're trending down, or the vibrations are going up or down. And there's a lot more you can configure using our tools. You can even have local indications through LED if some thresholds are crossed. Or you can, as I mentioned earlier, you can wire it up to an external alarm that'll sound in your plant if some critical asset is going out of the way. And then of course, it is an IP68 sense, so you can leave it out there. So it's got some dust resistance and water resistance out there. A little bit more deep dive, especially when we go vibration monitoring. As such, there's different things you can do, but again, I'm talking about these sensors can be monitored based on time. It can be monitored based on frequency of different vibrations coming in. It has capabilities of automatically teaching it the limits, so that based on the operation, and then easy interpretation of, sorry, I apologize, it's a spelling mistake there, but easy interpretation of motors, as we go along. Quick example, I mentioned this in the past, so we're not just giving you raw data, we're taking the data that's coming in, we're taking it over a period of time, which you see here called processing time. During that time, we are doing the analysis to see, hey, what's happening? And then giving it. So here comes the raw data, block one. We take that data, we process it here. Then we take the next set of block data. So it's not, so what you're giving you is an actual analytical data, not just raw data coming in. And that's one sweet thing about this sensor. There's a lot more analytics, though it is such a micro size, small little size sensor, but that's the capabilities out there. The other way you can do that is you can use it in two different ways. You can use it as a time domain or frequency domain. For some of you who are already savvy into vibration analysis, this would make sense to you, but basically, if I go in a very simplistic term, when and how severe do abnormal vibrations events occur, you can do that based on time domain. And then frequency domain tells you exactly what is causing the vibration. So as part of this little sensor, you're getting all these values that are coming in. You can get I mentioned that root mean square acceleration, velocity, variance, skewness, kurtosis, you name it. And then on the vibration on the frequency side, you get the dominant peaks, fundamental peaks, and up to 16 peaks. Or just to explain, everything vibrates at different frequencies. Even on the motor, the bearing vibrates differently, the arms, the belts, anything else, they all have their own harmonics. And based on which peak is predominant or dominant, we can know where the problem is coming from. So just gives you, so these are some of the analytical tools available in the condition-based monitoring. And this is what you can take further and apply analytical tools, and then it becomes predictive maintenance. So here's an example. If ARMS is ramping up, we know it's a defective bearing, worn gears. If VRMS is moving up, then we know it's unbalanced, it's misalignment. If peak to peak is changing, then we know it's bearing damage having. And we can apply a lot of these rules in the and tell you exactly what is going wrong with this. The other thing to keep in mind is not just this, there is also an industry standards, ISO 10816. Of course, it's been refreshed. Now it's ISO 20816, but it's still the same, a few minor changes, but these are rules that applies. So we have that built into our tools in our sensors, so that if vibration is crossing a certain threshold, the velocity RMS, we can give you the appropriate alerts based on whether it's blue, green, yellow, or red. Fundamentally, the blue is where If you install a brand new, that's where it'll operate. B is a little wear and tear. C means things are not looking right. You can run it, but don't run it too long. And then D means don't run it at all. Stop it, because if you run it, it's going to damage this asset completely. So some examples, where would you use this kind of condition-based monitoring, and especially in manufacturing of vibration analysis? Well, these are some of the examples in different industries where you could use it, on cooling fans, on mills, on, somebody mentioned bandsaw, wood cutting, sawmills, conveyors. So there's not one little thing that this niche, this can be used anything. We are even seeing examples where people want to use it in the malls on the conveyors and escalators that are running to see the vibrations on the motors that run those, that if some of them start vibrating, those escalators are going to fail. And you can take preemptive maintenance on those, or predictive maintenance on those as well. So the examples and the applications are diverse, and it could be used multiple different ways. This is a little bit more detail. I don't want to bear too much on this one, but just to show that based on your history, I mentioned that earlier, if you knew how long it lasts and this stuff, you can set the max and the minimum limit, and then alarms. If you don't know it, you can leave it, let it run for a while, and let the system auto teach itself, and it'll know that if I'm running now, for example, then this is my normal operating vibration. So plus or minus 15% of this will be my threshold. If I start going more than 15%, that's my high. If I start going low, that's my low, and then things are not right there. The other one is based on if you had, and you have done a lot of vibration analysis on your machines in the past, what the thresholds are. You can manually set those up. And then now you don't have to do these random checks on these machines or call somebody, an external party or service to come in and do vibration analysis. Now you are getting real-time data, and as soon as things start switching one way or the other way, you get alerted right away. So there's two different ways to configure those. And this is back to what I mentioned earlier. You can have it as a local. You can just use it for condition monitoring and put a little alarm there, or tie into your PLCs out there. Or if you want to see the whole trend charts and how things, you can implement it as an on-premise solution. Or if you want to put it all the way up into a cloud, you can still do that too. Take an edge gateway and push it out there, and then you can have it software as a service where you can do the analysis and everything else in the top. This is another way how we do it in a cloud setting. We have edge gateways where you can pull the data into an edge gateway and push it up into the cloud where it can give you all the analysis and analytical data. I just want to throw that in to show that these are current solutions available today, and it's not futuristic. All the solutions exist today, and we're adding more and more of the analytics, the AI, the machine learning, other aspects into it, and then giving that to you in a browser available for you to do the analysis and on any alarming that happens. You can mount it different ways, and we give you all the accessories to do that. So just giving it's a complete solution that is already out there. So this is not futuristic predictive maintenance. It's here today. The prescriptive is where we are headed, and pretty soon with the way the technology is moving today, we will be there shortly with all the tools and analytical tools that is available to us. So I went through a lot. I covered a lot, but I wanted to focus on the condition-based monitoring because that is the Lego block, the smallest Lego block that leads to predictive maintenance, that leads to prescriptive maintenance. And hopefully we covered a lot of that, and you get a better understanding using just vibration analysis as an example. So that brings me to the end, and I'm going to go with Eric, if you have any questions or anything, ask questions or put it in the chat.
Exactly. Thank you, Divya. Not seeing any questions coming through yet, but we could give it a moment here. If you have any final thoughts, otherwise, I just want to let the group know that you can always find our future webinars on sick.com and through our newsletter, and want to thank everyone for joining. Not seeing any questions coming through here yet, but you can always contact us directly also at info@sick.com. Oh, we might have one or two questions coming in here. One question is, do you share the presentation? So just a note that, yeah, we will have the recording available to you. We'll email everyone who registered today. And here's a good question for DP. Is there a location on the website that covers the total solution offering?
Yes, there is a location, and we'll share that with you as well. Some of the websites are going through a revamp, so you will see this a little bit. It'll become more clear and easily accessible, but yeah, it is there. The whole solution, the 1, 2, and 3 that I showed earlier in the previous slide will be available.
Great. Not sure if you're looking at these DP, but the next question is, what are the solution offerings to parcel sorting maintenance?
Good question. Again, going back to my top when I started was, Eric, if you can pause, mute yourself. I'm getting feedback here. Yeah, sorry, thanks. So one of the things which we are seeing out there is, condition-based monitoring. Now, condition could be anything. So if you're looking at parcel sorting machines and you are worried about, the read errors, that is a critical asset that that things are getting dirty or there's more read-write errors coming through. That would be an asset, and then we have a solution based on package analytics that is available for you for monitoring those and for looking at other aspects. So going back to when I say predictive maintenance, it is applicable across. I used an example of vibration analysis, but it doesn't have to be. Any variable that you can see that gives you a good insight into the health based using a sensor would be what we call a condition-based monitoring. So if read-write error for a parcel sorting machine is what you want, and that's what you want to focus on, then that would be the asset you want to monitor for condition-based monitoring. If it is the conveyors that goes underneath and you want to see that is okay and not going out of whack, then we put a vibration analysis on the motors that run on the conveyors. So you look at your machinery and you see what is critical and what you want to know, and then those sensors you apply and bring that in. Now you get your condition-based monitoring. Hopefully I answered your question.
Great. I do have one more question here. In your opinion, what is the most challenging part in the implementation of predictive maintenance?
It's a good question. The biggest challenge right now is to understand what is your current install state. If you have a standalone machine that is just running by itself with no automation, no electrical power next to it or something else, then putting all the solutions in, you need a little bit of, you got to bring in a panel, you got to mount the sensors, you got to wire the sensors. So you need a little bit of electrical contractor work or electrical work to wire all this stuff around. But you get a solid industrial solution. So that is the investment that you have to do for the installation part. But once you got it going, if you get the ROI very, very quickly because it gives you an insight of how well you're running. And if you made any changes, it can let you know if you did the right thing or you did not.
Excellent. And I don't know if you'll have the answers for these questions, but we do have a couple questions concerning availability, trial samples, pricing. I don't know if that's best left for sales DP or if you can answer any of those.
Yeah, well, reach out to your local MPMs, MAEs that we have from SICK. If you're a distributor, reach out to a distributor next to you, but reach out to your SICK sales representative, and they will be more than happy to work with you to do demos or to give you trials. And so yeah, so that's approach the sales channel.
All right, great. Looks like that was the final question there. So I just want to once again thank our attendees and of course thanks to our presenter. Appreciate it, Divya.
Thank you, everyone. Thanks for participating. Bye.